Good evening, sir, and good evening, everyone else. So today we have very first lecture on numerical analysis. So we are targeting this topic for all set exams as well as for net exam as well. So I'm writing and net exam. See, I have not given TG set exam or set exams because our state Uttar Pradesh does not conduct this exam. So I have not given the exam, but I have given the net exam and I have qualified that exam nicely. So before starting the topic, let me give you a brief introduction about the topic. In this topic, we will be taking around 8 to 10 classes. 8 classes are enough for finishing the subject and 2 classes for problem solving and for your queries. Because when I saw the exam of TG set, they ask every time 3 to 4 questions from this topic and the questions are very basic. You don't need to study the whole numerical analysis in a deeply manner. You just need to target the points by points and target the problems, because they are not asking the theory or they are not asking the theoretical problems. They are just expecting that you know the method and how to apply. That's enough. In this class, we will be starting the first topic. Let me give you an introduction that how many topics we are going to cover. In numerical analysis, the first topic is root finding method. And every time in set exam, there is a one question in your TG set exam. One question is fixed from this section. I hope my voice, video, everything is fine. If you face any difficulty, you just ask in the comment or you just ask in the mic. The second topic will be interpolation. Generally, one question is from this section. Number 3, numerical differentiation and integration. Again, 0 to 2 questions from this section. Sometimes they ask no problem, sometimes they ask one problem from integration, one problem from differentiation. The next is numerical solution of ODE. And the last topic is solution of system of linear equations. So these are the 5 topics we are going to cover in this topic. And I must say, if you are a student of mathematics or statistics, does not matter, because you already know the mathematics till BSc level. And for attempting this topic, you don't need much thing. If your basics are fine, then you will be able to attempt every problem. So I must say, it is doable in exam. So either you are from mathematics background or statistics background, do prepare this topic for your SET or NET exam. In both exams, you will be getting many questions and the questions are easy to attempt. They are not like topology or linear algebra or real analysis that if you study whole linear algebra, then there is a chance to attempt 50 or 60%. But in this scenario, if you study 100%, you will be able to attempt 80 to 90% in examination, either NET or TG set exam or any other set exam. Okay, any question, any query regarding this topic, any student? Anything in your mind? Because then I will start the lecture. And let me mark the question. Yeah. One question from this and 0 to 1 question from this topic. So generally they ask 3 to 4 or 3 to 5 problems in examination. Okay, cool. So let's begin the topic. Na? The first topic is root finding method. See, suppose we have given some equation that is algebraic or transcendental. For example, suppose we have given that find roots of x square minus 2. So what you will do, you will say, sir, why you are asking this problem? The roots are x is equal to plus minus square root of 2. So you will say x is equal to square root of plus minus 2. But suppose if I ask you find roots of x to the power 4 plus 3x square plus x minus 100. Or let me make it more complicated. Then you will not be able to find the roots explicitly. So in that case, you demand that you need some method that works numerically. Because in this case, we don't have any accurate way. For this, we have Sridharacharya formula to find the roots of a quadratic polynomial. But for some other complicated equation that involves trigonometric or logarithmic or exponential functions, those are generally called transcendental functions. So there is no method to find the roots of this equation. So for that purpose, we demand this topic root finding method, and this is a numerical technique to find the roots. So for this kind of equation, we need root finding methods, and we have 3 to 4 methods in this topic. Let me begin with the very important one. The first is Newton-Raphson. See, I'll go in my way. First, I'll tell you the topic. First, I'll tell you the method. Then I'll give you some example. Then I'll give you basic definitions related to what is the order of convergence, rate of convergence, that I will give you later. Don't worry. Just have trust on me. So the very first method is Newton-Raphson method. This is most important for your examination. If there is a problem from root finding method, 99% are chances the question from Newton-Raphson method. Let me give you the method first. See what happens in this method. Suppose I am giving you some function fx and I want to find the roots of this equation. That means I want to find the points where f is getting 0 or getting vanished, or it is touch, or the graph of f is touching the x-axis. Because if you draw the graph of f, so suppose the graph is like this. So you are feeling that this is one root and this is one root. Root means where the function is getting vanished or is becoming 0. So we are looking for the solution of this fx is equal to 0. Let's suppose I know that alpha is my exact root. So I am having f at alpha is 0, and also assume that f dash of alpha is non-zero. I'll tell you later why we are considering this one, and I'll give you the whole theory. So suppose we know the function has alpha as a root and alpha is a simple root. Simple root means function is becoming 0 at alpha, but f dash is not 0 at point alpha. So let me generate a scheme. Initial guess. See, in numerical methods, what happens? We deal the things numerically or iteratively generally. Iteration means every step depends on the previous steps, either previous one step or previous 2 steps or previous many steps or finitely many steps. Those are called the numerical schemes or iterations. So let's suppose initial guess is x0. So if you give me one initial guess x0, I will generate the scheme. Let me generate the scheme. Suppose your function is like this, and where it is touching the x-axis, this is the exact root alpha. Let's call that point alpha. So initial guess is x0. So you are assuming, suppose x0 is the exact z, or suppose x0 is the approximate 0. So what you will do? You will put your x0 here. So what Newton-Raphson did in this method, you take this x0, take the point x0 comma fx0 on the graph, and just take the tangent passing through this point. Take the tangent passing through this point. So when wherever it cuts on x-axis, and repeat the process. So what will happen? Now we have 2 points. This point is x0 comma fx0, and this point x1 comma 0. Do you know that the tangent, or what tangent says, or what is the slope of the tangent? If I want to find the slope of this tangent at point x0, that will be given by f dash of x0. What is f dash of x0? It will be slope of the tangent passing through x0 comma fx0 So f dash of x0 represents slope of the tangent passing through x0 comma fx0. If I ask you, suppose you have this tangent line that is passing through these 2 points x1 comma 0 and x0 comma fx0, can you tell me the slope? Do you know the slope of a tangent line that passes through 2 points? This is given by y2 minus y1 upon x2 minus x1. So according to this method, your f dash of x1 x0 should be given by y2 minus y1 over x2 minus x1. Now, what is y2? Because it is passing through x1 0 and x0 fx0. So we can say fx0 minus 0 over x0 minus x1. Fine. So this should be the tangent. So from here you will be feeling x0 minus x1, it will be fx1 over f dash of x0. So your x1 will be x0 minus, it should be fx0, f dash of x0. So this is your first iteration, or you can say the second, because first is x0, that you assume that it is the initial guess. So now you will be feeling, suppose this is the iteration, so by the same procedure we can find the next iteration. See what will happen. Now you feel the method, because till now you have not felt the method. Say this is your point x1. Now you go to this point, call it x1 comma fx1, and try it on your notebook. Now you find the tangent at this point. So tangent will be like this. So you will be feeling that you are very near to the root. That means graphically this method is working. Graphically this method is working. So with the same procedure, if you find the line passing through x, or tangent passing through x1 comma fx1, and this point will be called as a x2 comma 0, the third iteration. So you will be feeling with the same procedure, your x2 will be, or in general I can say the n plus 1th iteration will be given by xn minus f of xn divided by f prime of xn. Is the procedure fine?
Yes, sir.
Now, there might be some problem in your mind. What is the guarantee of this method? Whether this method will always give you the nice results or not. See, in this example, what is happening? When I'm taking my x naught sufficiently close to alpha, so after 1 or 2 or 3 steps, I am seeing, or you all are seeing, that we are near to alpha. My sequence of iterates x naught, x1, x2 is converging to alpha. This is you all are feeling. But suppose let me take one more situation. Let me take one more situation. Situation where, let me call in the short, this is NR method, Newton-Raphson method. Fails. Suppose my graph is like this. Suppose this is my graph. So what is the exact root? Let's call this alpha because it is the point where it is crossing the x-axis or touching the x-axis. Now, suppose you have chosen your x naught here. Now, what is the procedure? You go to this point, call it x naught comma fx naught. Then you take the tangent at this point. So what will be the tangent? This is the tangent. Fine. And where it touches the x-axis, you call it x1. And you apply the process again. So this is x1, then this is your x2 comma, okay, this is x1 comma fx1. So now you take the next tangent, this will be like this. So now this will be your x3. So you might be feeling that you are getting away from the root. Your scheme is not near to alpha. It is away from alpha. So what does it telling you? That this method need not to converge always. Or the scheme need not to converge to your exact root alpha always. Getting it? Now I think the method is quite fine. Let me give you one problem. See how they ask the problem in your examination. Okay, let me give. Just 1 second. Let me show you on your screen.
Please note down all of you. నేను ఆల్రెడీ సార్కు టీజీ సెట్ ఏపీ సెట్ క్వశ్చన్ పేపర్స్ పంపించానండి. ఆ క్వశ్చన్స్ ఎక్కువ కవర్ చేస్తూ ఉంటారు. దాన్ని విన్న తర్వాత మీరు ఆలోచించుకోండి క్వశ్చన్ చేయగలుగుతామా లేవా అనేది మీరు చూడండి. సో ఐ హావ్ ఫార్వర్డ్ ఆల్ ద ప్రీవియస్ టీజీ సెట్ అండ్ ఏపీ సెట్ క్వశ్చన్స్ టు ది మనీష్ సార్. మీ డౌట్స్ ఉన్నా కూడా మీరు అడగండి, ఎక్కడ డౌట్స్ వచ్చినా కూడా మీరు అడగండి. Feel free to ask any questions.
Are you able to see my screen?
Yes, sir.
See, this is the problem. I hope it is readable.